So to do that, I want to give you a bit of a framework to think about this. And that framework is something that I came up with a co-author, Mark Mueller, who's a physicist / proprietary trader in finance. We came up with this back in 2010. And it's the 5 levels of risk and uncertainty. And I want to explain why we need 5 levels, because, well, you'll see in a minute that it actually matches very nicely with drug development. So first, let me tell you what the 5 levels are. Here they are. The first level of risk and uncertainty is no risk or uncertainty. In other words, what we did for the first part of this course. Everything is known in advance and for certain. The second level is risk without uncertainty. By risk, I mean the kind of statistical distributions that we can quantify versus the uncertainty that the Ellsberg paradox referred to in that very first class that we went over. So if you have pure risk, meaning you can quantify the probabilities of your upside and your downside, and you know for a fact that your distribution is exactly the correct distribution, then that's level 2, uncertainty. Level 3 is what I call fully reducible uncertainty. This is the kind of uncertainty that eventually, with enough data, with enough trials, with a large enough portfolio, eventually it settles down to risk. So I'm thinking about the law of large numbers and the central limit theorem. You've probably come across that in some of your courses, in DMD, for example. The basic idea there is that we don't know the distribution, but with a large enough sample, we're pretty confident that it'll be approximately normal or log normal, depending on the nature of the limit laws that you use. So even though you don't know the distribution, as in the case with level 2, it doesn't matter because with a large enough sample, you're close enough. And now, level 4 uncertainty gets to be a real problem. Level 4 uncertainty is what's known as partially reducible uncertainty. In this level, there's a part of the randomness that will never be known or understood. This is the unknown unknowns that people refer to. You don't even know what you don't know, and that's what can kill you. So this kind of randomness is very difficult to deal with. And there are some investors that are willing to take it on, but very few and far between. And then there's a 5th category that we actually even debated whether we needed a 5th category, but Mark, the physicist, actually felt that from a theoretical perspective, it was very important. And what he calls this is irreducible uncertainty. What we both agreed to call it is rather Zen uncertainty. That is, there is all attempts at understanding are futile. There is only suffering. This is a situation where you just know nothing, and you will never be able to know anything, and you have to acknowledge that that is a limit of human knowledge, and you should not be investing in anything that is Zen uncertain. Well, it turns out that if you look at these different kinds of uncertainty, and you array the different fields of academic knowledge, there's actually a very nice correspondence. So it turns out that mathematics, the queen of all sciences, that's at the very top, because 2 + 2, I know it equals 4. Perfect certainty. But once you leave the realm of mathematics, and even within mathematics, at the very foundation, there's a lot of messiness and uncertainty. But I want to give you an example of how we move from one kind of uncertainty to another, all of these different levels, okay? And I'm going to start with a solar eclipse. I don't know how many of you are history buffs, but if you are, you know that at one point, a solar eclipse was viewed as Zen uncertainty. Nobody understood why it happened, how it happened, or how to even predict when it was going to happen. All they knew was this was a really big and serious event. I mean, if you think about it, you know, you're living in an age where you depend on the sun for your life, and all of a sudden somebody turns off the light switch. You might consider freaking out at that moment. In fact, on May the 28th, 585 BC, people did freak out. There was a war going on. And when a solar eclipse occurred, it was viewed as a religious portent. And so it turns out that the Lydians and the Medes put down their swords and shields because they were so freaked out. Now, I have no idea how long that lasted, hopefully more than the time of the eclipse. But at that level, a solar eclipse is level 5. Where are we today? Today, thanks to mathematics and physics, it's completely deterministic. In fact, I'll have you know that we've got an eclipse coming up. I don't know how many of you realize this, but it turns out that in August, let's see, August 21st, 2017, there is going to be a solar eclipse which will be visible from the United States. And in case you want to know when that's going to happen, NASA has very kindly put together a countdown clock, 24 weeks, 5 days, 18 hours, 2 minutes, and 4, 3, 2, 1, and so on. We can predict this down to the millisecond when the eclipse is going to occur. Perfect certainty. What's the difference between what happened in 585 versus today? The difference is we're smarter. We've developed understanding to move from different categories. Well, that's the point about biomedicine. It's that we start off at uncertainty and eventually we get to risk. If we can actually make that transition with science, all the better. So one of the reasons why the FDA approved Herceptin so quickly is because it wasn't just a black box. Here, let's throw some chemicals at these patients, and gee, it seems to help out a number of them. That's a good drug. It was, here's a theory, here's a mechanism, here's evidence, and we've got all of the data from literally tens, scores of scientific papers that demonstrate this mechanism works. That reduces uncertainty to risk, and investors, as well as regulators, take that seriously. So they said, gee, you know, this stuff really looks like it's working, and you tell us that it works in this patient, but it's not in this patient, and in fact, that's exactly what happens. We're going to approve this thing. This is great. This is fantastic. In fact, patients who were not part of the clinical trial pushed to get admitted to the clinical trial because it was demonstrating the shrinkage of tumors after just a few days of exposure to Herceptin. So the way to deal with uncertainty is to reduce it to ultimately risk, and then if you can, in these wonderful cases, perfect certainty. So let's get back now to finance. Occasionally, this won't stop wars, but it'll stop traffic. Occasionally, we now will then be able to change these levels to the various intermediate points. And one of the things that I want to emphasize is that we can actually change them financially as well as scientifically. This is a case where science allowed us to change the level from 5 to 1, but we're going to see over the course of the next few weeks that there are certain ways by using financial methods we can change the level of uncertainty to certain kinds of risk.